Well, thank you for joining me. This is a session about adding live streaming to your application without being a video expert. I don't know how many of you have a need for live video in your applications. I know it's kind of a thing that not everybody has an immediate need for, but it's something that I do every day and I love to talk about. And I'm really, really happy that you all decided to join me this morning and learn a little bit about it. Hope you enjoy. I'm Todd Sharp. I am from Georgia in the United States. I've been writing code for 20 plus years. And back when I started writing code, we just called it being a developer. Now it's probably what you would call being like a full stack developer. So SQL and backend and front ends and all of that good stuff. We've kind of segmented a little bit these days, but how many of you write front end code most of the time? Okay, about half. And also back end or just front end? Also? How big is serverless these days here in this area? No, not big? Lambdas, those kind of things? Some of you. Okay, good. I'm glad to see that. I think serverless has a good place. I'm already going off track here, but I think serverless has a place, but I don't think it's quite the magic bullet that we've put it to be in some places. So I'm a developer advocate for Amazon Interactive Video Service. I've been doing that role for 2 years. If you are wondering, this is the United States, and that is where I live in the northern part of the state of Georgia on the southeast part of the US. If you are wondering, no, I did not vote for him, so I am just as sad as the rest of you. But we will get through the next 4 years and hopefully without too much damage. Yeah, let's see. So let's talk about building a live streaming application. I want to jump right into it because there's a lot involved. To really build a proper live streaming application, or it's more than just an application. You first have to create a global network of virtual machines to ingest the videos or accept the video from a user. And then you need to transcode that video to deliver it to the viewers. If you want to do this the right way, you're going to have to develop transcoding and packaging software. There are some off-the-shelf products that you can use for these purposes, but you'll probably quickly find that those, although do a good job, there will always be some edge cases and some little things that they don't do a great job of. You also have to become an expert on video codecs and protocols, ingest protocols. Things like H.264, H.265, HEVC is the newer codec. RTMP, the real-time messaging protocol. HLS, which is HTTP live streaming. MP4, WebRTC, all of these things you're going to have to become an expert on. You're going to have to maintain those virtual machines, security patches, updates, these kinds of things. You're also going to have to worry about how to deliver that video to your viewers. So you're going to have to create a load-balanced global CDN that's optimized for video. Video is a different payload than traditional text or HTML, so you're going to have to create a CDN to handle that. Then you're going to have to worry about playback software. There's many, many low-end devices in the world, especially when you get into places like India or very remote areas where there's many, many low-end devices, older devices, low bandwidth networks. You're going to have to worry about all of these things. Then you're going to have to monitor things. Stream quality, observability. All of these things are what you're going to have to keep in mind. And you have to realize that live streaming is complicated. Here's a quote from a blog post that Twitch put out. I should mention, by the way, I didn't mention, I actually do work for Twitch. So I'm a Twitch employee. Twitch, the live streaming platform for gaming and IRL type streaming. Assume you've all heard of Twitch, fairly popular. So I work for Twitch. Twitch is also owned by Amazon, if you weren't familiar with that. So I live in a really weird space where I'm a Twitch employee, but I kind of work on an Amazon AWS service. But just to give you a little context, so in order to provide a streaming service that is both high quality and low latency for creators and viewers, Twitch has nearly 100 points of presence across different geographic locations in the world. And each of those POPs are connected to our private backbone network. and then distributed from various processing and distribution centers. There's a link there if you want to read much more about this. There must be an easier way, right? I mean, nobody has the time to build out these VM networks. Twitch took the time over the last 13 years to build this very robust global network for ingesting and delivering video. And that's where our superhero comes in. Every superhero has an origin story, and the origin story of Amazon Interactive Video Service is that it was born from Twitch. So again, Twitch supports millions of viewers daily, over 2 billion hours monthly, 1.35 trillion minutes watched in 2023. Obviously, as I said, we've spent many years really optimizing our network for this kind of traffic, and now we power these global live streaming experience. And this service is now available to you as of about 4 years ago as an AWS service called Amazon Interactive Video Service. So managed service allows you to create live streaming channels for various use cases. We'll look at each of those use cases and see how easy it is to get started, because you are all experts at creating applications. You know your users, you are experts in user experience and design and all of the business logic that you work on every day. We're the video experts, so we can work together and we can create live streaming experiences for your users. So Amazon IVS has 3 different major capabilities. The first is called low latency streaming, and that is the type of streaming that you would get if you went to twitch.tv today and you clicked on a live stream. This is delivered via low latency streaming. The latency is about 2 to 5 seconds typically from glass to glass, from the glass of your webcam to the glass of your viewers. It's about 2 to 5 seconds. And for most use cases, when you think of traditional live streaming, this is an acceptable delay. It's not too long where it feels disconnected if you have a chat experience, but it's not real-time streaming. And for real-time streaming, we do have an offering that we call Stages that offers video with latency as low as, well, we say as low as 300 milliseconds, but in practice, I've seen it much lower than that. Around 100 is typically what I see. And this is what we call conversational latency. So if Anton and I wanted to do a live stream together, a Google Meet, FaceTime style conversation, this is the kind of feature that you would use for that kind of experience. And finally, we have chat, which is a very basic, oh, well, I shouldn't say basic. It's a full-featured chat solution that allows you to integrate chat and other interactions into your applications. The key being managed service, right? Like I said, we make these things very easy to use so that you can focus on your business logic, and we will focus on the difficulty of delivering live video. So let's talk about low latency streaming. These are some of the features in our low latency offering. Some of these words might be a little confusing to you, but the important thing again is that 2 to 5 seconds of latency, 1 million plus viewers. I think the current record was set in Spain over the summer. There was a boxing event, and I think they had 3.4 million viewers on one stream. So very, very capable of scaling to many millions of viewers. And the quality is really, really good, up to 1080p. And that's because that 2 to 5 seconds allows us to really deliver the best quality video. Bless you. You're welcome. Some of the use cases for this: UGC, user-generated content, so your typical gaming style, or IRL, in real life streaming, where people are sitting at a cafe and talking about their day. I actually did a live stream 2 nights ago from the McDonald's across the street at 10 p.m. at night. I have a weekly live stream. I felt a little funny sitting in a McDonald's and live streaming, but I don't think that's something that we're not used to seeing these days. This is, you know, we always see people with their phones out or their laptops out and their camera on, and they're just talking to nobody, and it doesn't feel strange to us anymore. And that's okay. Live events, so things like this right here. We could be live streaming this event to a global audience with Amazon Interactive Video Service, low latency streaming, and we could monetize that. If the conference organizers want to talk about adding a future virtual ticket where they can broadcast all of these sessions to remote viewers and have playback authorization and make sure that only authenticated users are watching, all of that is possible with low latency streaming. Live shopping. Sports and fitness are another one that we're seeing a lot of. So there's a trainer that stands in front of the camera and they do maybe a cycle or exercises, and they're leading a class remotely to people who sign up to their website. And of course, gaming, esports, very big here, right? Yes, esports. So these are the kinds of use cases. And honestly, there are 3 steps that it takes to get started with low latency streaming. It's very, very simple. You create a channel, what we call a channel. It is a single resource for one stream to be broadcast to many viewers. It's just a resource in the AWS console or via the CLI or the SDK. You broadcast. You can use any broadcasting, well, most broadcasting software to broadcast to a channel. OBS is a very popular one that a lot of streamers use. But we also have a web broadcast SDK. We have mobile SDKs, all of these to allow you to broadcast to a channel. And then finally, playback. Of course, if somebody wants to view your stream, you're going to have a playback experience. So we have web and mobile SDKs for that. Let's actually get started and see what it takes to do that. So I'm going to do it live here, as they say, and I'm going to create a channel. So I'm going to use the AWS CLI. And to do that, I just type the command AWS IVS create channel, and I give it a name. In this case, I'm going to pronounce this terribly, or somebody help me? Øredev demo. And we just hit enter. And the thing that surprised me about this process when I first started using IVS is this is done. It's immediately ready for us to live stream to. There's no spin up time. We don't have to wait. We can immediately start streaming to this channel. So we have an ARN, which is the Amazon resource name. It's just a unique identifier. We have some other properties here. We can ignore most of them for now. They're a little more advanced. But this ingest endpoint is something we're going to need. So I'm going to copy that. I'm going to come over to my editor. Can we see this okay? Good size? Good. And if I scroll down here and I paste that into my ingest endpoint variable, I've got that set. And then come back to the terminal. And if I scroll down a little bit, I have a property called stream key. And this is the password, so to speak, of this channel. So if we copy that value and we paste that stream key into our code, we're ready to start streaming to this channel directly with this application. Now let's walk through really quickly this demo. So there's 61 lines of code here, inclusive of the HTML and a tiny little bit of styling that I have. We have the Amazon IVS Web Broadcast SDK that we're including. We could npm install this if we're using a Webpack or something like that to bundle our assets. In this case, I'm just including it directly. And of course, this works perfectly with React or Angular or any framework that you are using today. I'm just simplifying it for this demo purposes. And then I have an inline script module. Of course, again, probably wouldn't do this normally, but I have my stream key, my ingest endpoint. I create a broadcast client by calling IVS broadcast client.create. I pass it a stream configuration, and this is a preset object in the SDK that contains information about the width, the height, the frame rate, the aspect ratio, all of those types of things. It's preset, so we don't have to manually set all those. We can just use the standard preset. And then I pass it the ingest endpoint. I need to get permissions to use the camera and microphone for the user, so I call get user media, passing true for audio and video. And this will prompt the user in the browser to allow permission to access those devices. The next thing I do, I have a canvas element here in the HTML, and I want to preview that. So when we're live streaming, our users typically want to see what they look like as they're broadcasting to the world. So on this canvas, I call attach preview, or on the client, I call attach preview, passing it the canvas element, a reference to the canvas element. And then I need a stream from the camera and the microphone. So to obtain those, I can call enumerate devices with JavaScript. This will give me an array of all of the possible input devices on that machine. If we wanted to create a drop-down and allow them to select a camera, we could populate a select list from that. But in this case, I'm just going to grab the first camera and microphone. So I'll filter out that list of devices based on the kind. So for video input, I set that into video devices, and the same for audio devices. And then I call get user media again, but this time I actually pass it a device ID. So this is the specific unique identifier for this camera. Again, like I said, I'm just grabbing the first one in that array and passing that to get user media. And I will actually get a stream back from this that I can use to broadcast. Once I have a camera and microphone stream, I add those to the client, giving them a unique name. Index here is so that you can actually layer multiple streams on top of each other, and you can actually position them. So for example, if you wanted to do screen share, you could use get display media, and you can add that at index 0, and then get the camera stream, add that at layer 1, position it bottom right, whatever you wanted to do, something like that. Totally possible. And all I need to do at this point is call start broadcast and pass it the stream key. So now that I've explained all that, if I save this page and I head over to my browser and I click broadcast, it's hard to see down there, but it says broadcast started in the console. So I'm now broadcasting to this channel directly from an HTML web page in my browser. Now playback is the next obvious step of the process. So if we come over to the low latency playback page, this is even simpler. On line 8, we include the Amazon IVS Player SDK. And then down here in the JavaScript, we just create an instance of the player. We attach the video element from the page, so a video tag right here. We get a reference to that, and we pass that to the player. Then we load the playback URL, and we call play. If I come back to here, we can see that I have a playback URL that was created for me. So if I copy that, yeah. Oh, it's still not copying. There. So if I paste that in here, okay, that looks right. And I save that. So I'm still broadcasting here. If I open the playback tab and cross my fingers, there we go. So there's my playback. And you can see it's about 3 seconds of latency right now, right? Yeah, so it's around there. So this is low latency streaming. That took me 7 minutes, including all of the talking that I was doing along the way to explain what was going on. Honestly, if I was just going straight through, it would have taken me about 30 seconds to get that whole experience ready. So again, managed, very easy to add. You can of course style this. I'm going to close this so I stop looking at myself while I'm presenting. So very easy to do, very easy to get started. We can also, if we wanted to, come into OBS. I didn't plan this, so why not? We'll see if it works. Of course it will work. So if I come into OBS and I come into settings, stream, and I have custom here. So I'm going to use this. This is the correct ingest endpoint. I've already put that in there before. And if I take my stream key from here and I paste that in here and I click start streaming. So looks like we are connected. We are broadcasting. Everything looks good. So I have this custom layout that I'm using with a screen share and my video in the bottom. And if we come back to the playback tab, we can see that it's broadcasting. So we can use third-party software very easily, like OBS. Oh, we've got infinite mirroring there. I totally did that on purpose. So very easy to get started with low latency streaming. I do have this kind of little hack in here. If you are a Twitch user, A little fun fact is the fact that our web broadcast SDK can also be used to broadcast to a Twitch channel. So if you wanted to create a custom experience for somebody to broadcast to Twitch from a browser, because today if you go to Twitch, typically there's not a web-based, desktop-based way to broadcast to a Twitch channel. You usually have to use third-party OBS or your mobile device or something like that. So if you wanted to create a Twitch experience, you could actually do that as well. And to do that, it's all the same code. The only difference is you find the ingest endpoint for Twitch, which if you Google it, you'll find this page here that tells you the recommended ingest endpoints. So if you use the Twitch ingest endpoint and you use your Twitch stream key, you can actually broadcast to Twitch with the Amazon IVS Web Broadcast SDK. So if I open up that tab and I give it just a second to get started, you can see that I am actually broadcasting to Twitch right now directly from that web page. So, of course, Amazon IVS being a managed service, if you wanted to create your own custom experience, you could do that. But little life hack, you can also broadcast directly to Twitch using that SDK. So I'll stop that and we will. I should also point out here, if you do go into the Amazon IVS console in the AWS console, you can actually, if I refresh, there's my channel. You can actually test all this out directly from the console. So you can come into the console and there's already a pre-built broadcast and playback experience right here in the AWS console. So that's another option too if you're just looking to get started and try things out. So I'll stop OBS and I'll close that. And we'll head back here. So real-time streaming. Real-time streaming became really popular during COVID when everybody was at home. A lot of people were doing live streaming and a lot of businesses and companies were doing remote meetings, right? We started using Zoom and Google Meet and Microsoft Teams. What's the biggest one here? What do people use, companies use a lot? Zoom? Depends. Yeah. Yeah, so those kind of tools became really popular during COVID because most of us were working from home and we needed to stay connected. So this is when we also started seeing people asking on Twitch to be able to stream with another user. So they wanted to be able to stream with their friends who may not be physically located with them, but that 2 to 5 seconds of latency was too much. If I asked you a question and I had to wait 3 seconds until you heard me ask the question and then respond, that's not a very good experience for users. So we came up with this real-time streaming option to allow to address that situation. And again, the latency we say is lower than 300 milliseconds. We can have up to 12 hosts. What we call hosts are people who are broadcasting and subscribing, publishing and subscribing video. You can have up to 25,000 concurrent viewers. That is limited to 720p currently, which for most what we call like face streams, any kind of talking head content, 720p is typically an acceptable quality for that kind of content. I would say that you should probably keep an eye on this if you are interested in higher quality. That may be something that's coming soon. But for certain, 720 is really good for this kind of thing. No spin up time again. You create a stage and it's ready to go. We have various ingest options. We have all kinds of monitoring. We have record to S3, which is also available for low latency. If you wanted to record all of your live streams to S3 and play them back later on as a video on demand, or tape your company meeting and make that available to employees later on so they can watch it, that is certainly very, very easy to do. And we have something called simulcast, which addresses the low-end devices and poor bandwidth networks that allows you to broadcast various qualities, various renditions of quality. And the receiving device, our SDK is intelligent and picks the correct playback quality depending on the network capabilities and the device capabilities. Use cases, we see a lot of, in Asia, we see a lot of this, what's called PK mode. There we go. So PK mode or versus mode, where people have karaoke competitions. They sing with each other, or they do dance-offs, or they do cooking competitions, whatever they may do. Is really popular. And again, that requires that real-time latency. Guest star spots where a streamer is streaming and they want to bring in their friend or an expert. You could even do like a call-in style situation where somebody in chat, they can actually request to join the stream and you can send them an invitation and they can immediately join you. We have audio only. So if you wanted to do like a call-in radio show where the chat can ask questions on audio, that's also available. So there's web conferencing. Live retail is another really exciting use case. We're seeing companies, there's a company here in Europe called VOGGT, V-O-G-G-T. I'm not sure where they're based out of, but they do a live auction platform where people can auction off clothing, or another big one is called Whatnot in the US, and they auction off trading cards like Pokemon cards, and baseball cards, football cards, soccer cards, football, I guess. But they'll put the card up for auction, and in 30 seconds, people are bidding on this card, and it's really exciting. People are bidding really quickly, and you need that real-time latency because it wouldn't be fair if one user had 2 seconds of latency because they were closer to the server and they had 5 seconds of latency. You would have an advantage in bidding because you see the stream 2 seconds before she saw it. So that's where this real-time latency is really important in live auctions, online classrooms. Fan chats and influencer chats are, again, really popular in the APAC region where there's K-pop idols or Japanese pop idols will do chats with their fans, these kind of things. I'm not sure how much of that happens here, but certainly is a possibility. Let's get it started. Let's make it happen. So getting started with real-time is a little more work than low latency because you have to accommodate the participants joining and leaving, so it takes a little more code, but we'll take a look at how quickly we can get started with that. So let's head back to the console. Let's create a stage, which is the resource that we call for real-time streams. And we'll call this one test stage. And if I hit enter, I now have a stage created. I copy the ARN. And if I paste that into my code, we'll quickly go over the rest of the code here. So the first thing we need to do is get a token. So each participant, each broadcaster, and viewer needs a token. It's essentially a JWT that authorizes them. It allows you to do things later on like disconnect them if there's any kind of abuse or moderation needs. And it just helps you track who is connected up to that real-time stage. So I have a Lambda created here that will get that token for me. It just uses our SDK to issue the token. Very, very simple. So I call that, I get this stage token. Again, I get the devices and filter them based on camera and microphone. And then I have here what's called a strategy object. So this is just an object, and it has a reference to our local audio stream, our local video stream, and then 3 functions. This is it's not something that you'll use often or customize often, but it gives you the ability to do things like have a admin user who's not broadcasting, who can control who's connected, gives you some flexibility for that. But for most cases, you're always going to be subscribing to audio and video. You're always going to be publishing the participant. So it's a very basic kind of strategy object that is customizable. We create an instance of the stage, passing the token and the strategy, and then we listen for events. So we say stage.on. When participant streams are added, we want to add those or render those to the DOM. So we have a property in that participant object that event handler receives to know whether or not it's the local participant. So if it's the participant in this browser who's broadcasting, you don't want to add the audio because then you'll have audio echo back to yourself. So you don't want to hear your own audio. So we just want to make sure we check for that and only display the video when it's a local participant. And then we have a video object that we just create a new media stream, and then we add the tracks from this stream to that media stream. And that's it. And then we call stage.join, and we have entered the stage, and we're broadcasting. So if we come over to that, and we click real time, so now I'm broadcasting to the stage in real time. Is there any brave person who would like to join me from their mobile device? Okay, you. So I'm going to create a local tunnel here, and I'm going to create a QR code, and you will be able to scan this QR code and join me. Okay, so that's the QR code. If you can you see that? Okay, good. So if you click allow it to access your, there we go. Right? Look at that. So we have a real-time stream. Oh, someone else joined. So I didn't set it up for multiple participants. I'm sorry. But somebody took over. Okay. But you can see the latency here is immediate. I mean, this is not the 2 to 5 seconds of latency that we had with the previous one. We have a real-time stream that we can. Did you mute? Because I'm surprised it's not echoing. No? Okay. So, if you speak, it should be. Okay. Yeah. Okay, I muted that so we don't. So that's how quick it is to do a real-time stream with the Amazon IBS Web Broadcast SDK. We have about 8 minutes, is that right? Yeah, around there. So Stream Chat is another one. It's all WebSocket based, fully managed, very easy to use. We have both a web chat SDK, or you can just use regular WebSockets from JavaScript and connect up to the chat room. Very good latency, very good scaling. We do have moderation, so we can input a Lambda. We can define a Lambda handler so that every single message that gets sent to that chat room will be intercepted by this Lambda, and we can do basic moderation censoring if that's what you feel like doing, or filtering certain keywords, things like that. You maybe use Gen AI to do some kind of content detection. That's a possibility as well. We also have manual moderation, so you can define a admin user who can delete messages, disconnect users, those sorts of things. Excuse me. One of the things that I'm really excited about is the capability to stream from games. I know there are some game development studios here in Malmo area. Is anybody from a game studio? Okay. Darn it. But I think this is really exciting because when you look at a Twitch, I don't know if anyone has ever signed up for Twitch and tried to stream a game. Has anybody done that here? A few people have. Is it very easy to get started? It's okay, right? It takes a little work. You have to go into the dashboard, get your stream key. You have to set up OBS, set up your scenes in OBS, put your stream key in. It takes a little bit of time to get familiar with the process of streaming from your desktop to Twitch. What I think is really exciting is if we were to be able to stream directly from a game to a web application and basically take all of that setup, lower the barrier to entry. So what I built was this demo that actually takes a Unity game and publishes the game to an IVS channel directly from the game itself. So it removes all of that configuration. But it also creates the ability with real-time streams to do truly interactive gaming. So there was something created a long time ago called Twitch Plays Pokemon, where chat would enter a move and the game would respond to that chat message and it would do the next move in Pokemon. I think these kind of experiences are exciting, but because Pokemon is a turn-based game, it works that way. You can type a chat, you can wait then it takes the turn. But when you're talking about a driving game or a fighting game, you need that real-time latency in order to really interact with the game from the chat. So in this demo, as I said, what I built was a game that broadcasts directly to a real-time stage. Viewers can watch in real time. Viewers can get multiple camera angles. A viewer can change the camera angle themselves. So they can actually rotate the camera, zoom it in and out, and not affect the gameplay at all. It's a very unique experience. They can also spawn elements into the game by sending messages back and forth between the chat and the game itself. And the game can listen for those messages and react accordingly. So if we have time, we can try this out here. It works better from Android devices, I should say. But if you hit this URL, and I will start the game over here because you'll need to see that. Okay. So I'll bring it up here just to make sure that we can see both. Somebody's already figured it out. Excellent. So I have my game. This small window is the game, and somebody's changing the camera angle. That's excellent. So we can do things like spawn these elements in real time. If you click those buttons, you can see somebody's already got me off the track. So we can actually create real-time interactive experiences. And when you click that wall button, that spawns in real time right in front of me. So you're actually changing my objective as I'm playing the game. And it just creates a really unique experience that I don't think is available in any other way, in any other platform today. I think it's just a really fun experience and really something unique that you can do with real-time streaming. So what else can you do? Thank you all for doing that. I appreciate that. Oh, and I can also, of course, I can also add my webcam in the game so we can live stream our webcam and things like that. So we also have chat integration down here. So somebody's typing hi, so we can see chat directly within the game itself. So really kind of unified experience that was really easy to get started with. I didn't have to take any time to enter a stream key or anything. I just started the game and I clicked play. It was the drop table users. Oh. It is not vulnerable to SQL injection attacks, but thank you for trying. I respect that. Is that the guy who did the hacking talk yesterday? Is that him? Is he out there? So really, really unique experience that you can create. What else can you do? Well, we're seeing, don't have time for this demo, but we're seeing live casino applications becoming really popular where there's a physical dealer who's dealing cards in a casino, and in real time, people can bet on a game of blackjack or something like that. I'll skip through that. But before we finish, I want to kind of highlight some demo applications that we do have that you can check out if you're interested. We have a full user-generated content kind of create your own Twitch type application. You could download that on GitHub and deploy it to your AWS application, get started really quickly and learn all about stream health monitoring, low latency streaming, real-time streaming, chat. It's kind of an all-in-one demo. Everything that you want to do with IVS is in that. A web conference demo, so if you want to deploy your own Google Meet type experience, you could do that with this. Of course, these are not, we don't recommend you use them in production. They're kind of demo type things, but really good way to learn about how to use this to create these types of experience. This one's becoming really popular. Client-side transcription, of course, generative AI and the rise of Whisper and real-time translations. This is becoming more popular. So this one actually uses Hugging Face to do real-time transcription of your audio while you're speaking, so you could have live captions Of course, the next step, once we get to the point where it's good enough, real-time translations would be the obvious next step of that. So you could reach a global audience with your live stream much easier. I'm really excited about that happening. An audio room demo, if you wanted to create your own, what's the Twitter circles? Is that what it's called? Something like that. You could use this to do something like that. We do have a website called ivs.rocks. It is a one-stop place to learn all of these things. All of those demos I showed you and more are available up on there. There's a pricing calculator. There is links to all of our documentation, things like that. So yeah, that's essentially it. I want to thank you all and appreciate you joining.